Okay, ladies and gentlemen, welcome to week 3 of xEssentials for year 2020. Tonight we have Jeff Lacey from Spader Christmas. He's going to tell you how to get started in RGB pixels, and you're in for a treat. So, Jeff, if you're ready.
All right. Well, good evening, everybody. Let's just get started. I have an About Me page. I haven't seen that yet, but I am the newly appointed Director of Solutions Engineering at Mutual Mobile. Prior to that, I did iOS engineering, which was basically writing applications for iPhones and iPads, and recently got an AWS certification as the as Solutions Architect Associate. Basically, all that means is I'm pretty decent with computers. I also have a YouTube channel called Spader Christmas. It's mainly a DIY channel, mostly pixel stuff, but I will sneak other things in there from time to time. And I am a Udemy instructor. I have a class on lighting. It's basically all the videos, all the information that you've seen or that you would see on my YouTube channel. I created a course. If somebody wants to go through a couple hours, kind of takes you through all the basics and stuff. So that's all about me. Some assumptions. I've seen a few of these presentations, and so I'm going on some assumptions for everybody that you have a picture of your house from the best viewing angle, and you'll have to figure out whatever that is of your house. You have some kind of plan for your display, outlining windows or doors, props, that kind of thing. The main thing that I've been told is you need to have plenty of vertical and horizontal lines. Most people have plenty of vertical lines because we're hanging pixels up, and the horizontals, I think, is what people tend to forget about. But make sure you have plenty of both, because effects going across the whole house look a lot better when you have verticals and horizontals. You've downloaded X-Lights, and you are ready to drink from a fire hose, because we got a lot of information coming at you tonight. And I'm just kidding, really. You probably know most of this stuff, but to take you through some of the basics of pixels. Typically, there are 3 LEDs in each bulb, or node, as we call them, a red, a green, and a blue. Now, with those 3 colors, you can mix them to create other colors. So if you mix red and green, you get yellow. Blue and red, you get magenta, on and on. If you turn all of them on, you get white. Now, there are some pixels called RGBW that basically has a white LED in there, and I'll get to why that's kind of important a little bit later. Those are not as common. Most of the common ones have red, green, or blue. Now, you do have other strings of pixels that have multiple LEDs in each node, but tonight we're just going to assume that you have 1 red, 1 green, and 1 blue, because then all my calculations will work out right. The most popular voltages, these run on DC voltage. Most popular is 12 volts or 5 volts. You can get 24 volts and maybe others, I don't know, but 12 and 5 is the most popular. 5-volt pixels are more electrically efficient. In other words, you will have less wasted energy. 12-volt pixels require less power injection, and so I suggest that people start with 12 volts and then venture into 5 when you've got a handle on things. It's just 12 volts are more forgiving than 5. A little bit about power consumption. Now, this used to be true for most of the strings that we got, and it's really not anymore, or not necessarily anymore. I've seen people that have half the current draw of this, but it used to be that we could say 1 LED pulls about 20 milliamps of current. So if you have all 3 of them on, that would be about 60 milliamps. I have since had, and we'd use 60 milliamps for the for doing, ballpark calculations. I've since had people fuss at me because they bought too much power supply because their pixels didn't pull that much. So check your pixels just to make sure, I guess would be the lesson there. Not all pixels are the same. There are dumb pixels. They call it, they're basically analog pixels. You change the color with voltage on one or more pins. And that controls the entire string. It's like the old incandescent lights. You could have a string of lights that would be on or off. Well, this goes a little bit further. You can have any brightness that you want and any color that you want, but the whole string follows that pattern. And then with smart pixels or digital pixels, those change color with serial data. And they are individually addressable. So you could have, one pixel that's red and the one right next to it be blue, and, all the way down the line. So those are data driven. Now, there's usually 3 wires. There's plus, minus, and then a data signal. If you have 4 wire pixels, those might have a clock. But, all the ones that I played with, well, no, I did have one string that had a clock, but most of them just have 3 wires that I've messed with. There are 4 wire pixels. So they, like I said, 12 or 5 volts. You need a power supply to convert your 110 or 220 volt AC mains house voltage down to 12 or 5 volts DC, depending on which ones you have. Using that 60 milliamps per node current draw, and that would be if all 3 are on to produce white. So we call that 100% white. 100 pixels would be 6 amps. And, I don't know anybody that runs their house with all the lights on, all white all the time. So it's going to be some value less than that probably if you have colors in there. Just a joke. I have a mixture of 12 volt and 5 volt pixels. So to keep me from plugging one into the wrong voltage, I have standardized on using 4 wire pigtails for my 12 volt lights and 3 wire pigtails for my 5 volt lights. And that was basically just because I started with 4 wire in case I ever got 4 wire pixels and they were all 12 volts, and it's kind of grown from there. You can just, the main thing is make sure that if you are running both voltages, you don't plug lights into the wrong power, and whatever you use to figure that out is fine. A little pixel theory here. So I think the 2811, 2812B is kind of the standard chip that are on all these pixels. Or at least a very popular one anyway, and it has an 8-bit color depth. And so it takes 8 bits for the red, 8 for the green, and 8 for the blue. So you get 24 bits bits of data to properly light up a pixel. So if you send data into a string of 5 pixels, you'd send 120 bits. The first pixel would pull off 24 bits, light up, and send the remaining bits down to the next pixel till you get all the way down the chain and there's no more bits left and all the lights are on. Now, how do you know to only send 120 bits? Well, you configure the controller and the controller figures that out, and you don't have to worry about it that much. So not a big deal. But they do need a source of serial data, and there's a couple of options that you have. There is a pixel tester that basically outputs serial data. Now, the one from Hanson Electronics, it's a little module like this, and it's got 76 pre-programmed patterns. Now, you probably wouldn't use this for a Christmas display because there's, it just turns the lights on and has some patterns. But if you're, having a dinner party and you want to string up some pixels, this might be a great thing for it. For the rest of us, use some sort of pixel controller, and what that does is it converts E131 to serial data, and I'll explain that in a second. And then, we create all kinds of custom patterns and animations using X lights, and I'll go into that a little bit further. So what is E131? Well, you can read this later, but it's a standard by the Entertainment Services and Technology Association. Basically, it's DMX over Ethernet. It brings up the concept of universes. There are 512 bytes of pixel data or channels in a universe. It's just a grouping. Don't have to worry about it other than that. Now, early controllers standardized on 510 bytes per universe, and this can trip you up a little bit. So the newer ones can handle 512, and the older ones were at 510. 510 is exactly 170 pixels. So there's 3 channels. So pixel number 171, you'd have 2 bytes of data in the first universe, and then the next universe would pick up that last channel. So it's confusing for humans, but computers don't care. So if your controller supports 512, then there's no need to waste 2 bytes per universe. So how do you get E131 data? Well, xLights, of course, is a sequence editor. It renders out what's called an FSEQ file. It's basically binary data for your controller. You can output directly to lights. In other words, there's a little switch in there that you can output from xLights, but it's really not designed to be a player. It's more of a sequence compiler. So you get everything looking like you wanted in xLights, and then you send that FSEQ file over to a scheduler or player and use that to actually play out to your lights. Some of the schedulers, there's Xschedule. It comes with the xLights download. It runs on Windows, Mac, or Linux. There used to be Falcon Pi Player, and then they added other things, so now it's just Falcon Player. That runs on BeagleBones, Raspberry Pis, various ESP modules. Basically, these are little single board computers. They're inexpensive, so that's why they're very popular. You don't have to tie up a very expensive computer to play your lights. And they have a master remote capability, both Xschedule and Falcon Player. One can be a master, and then you can have several remotes. So that can help you kind of split things up or put a prop across the street if you wanted to, something like that. So this is kind of a basic block diagram. You'll have your player. You'll have a controller, a power supply, and some pixels. And that's pretty much what I started out with. As you add more pixels, the diagram can get a little bit more complicated. You can have a master and one or more remotes, several different controllers, several strings of pixels, you adding more power supplies, but it's still basically the same block diagram of player, controller, and pixels. So for your first year shopping list, you'll need a pixel controller. And that's really kind of one of the more important things to get first, because that kind of determines what pixels you can get. Now, if you stick with the popular pixels, the WS2811s and WS2812Bs, they'll probably run just about anything because those are very popular pixels. But once you start getting into the more esoteric chips, that you may find that your controller doesn't support that. So like I say, the controller determines which pixels you get. You will need one or more DC power supplies because pixels pull more current than you think. Like I said, a string of 100 is 6 amps. I also recommend that people get several of the smaller power supplies. You can go and say, well, I got to get 1,000 amps of DC current. But if you have one power supply and something goes wrong, then your whole show is out. Whereas if you use I think we use the 350 watt variety, about 30 amps at 12 volts. If you have several of those and one of them goes out, well, then you can, if you have a spare, you can replace it, but you don't lose the whole show that way. So more smaller power supplies is kind of the recommendation there. You can use pretty much any power supply. I like the Meanwell brand of power supplies just because they're very well built. They are a little bit more expensive, but there's good circuitry in there, good protection in there that you may not find on some of the cheaper ones that you can find on Amazon. Where do you get pixels from? All the pixels come from China. Now, you can order directly from China, but there's a lot of people that buy them, in your country. There's several vendors in the United States. There's, I'm sure, vendors in Australia, other countries as well. So it really just kind of depends on your affinity for ordering from a foreign country. Some people just don't, they'll only buy local. Some people don't care. So it's really just kind of whatever works for you. Also, when you're, if you're going to buy from China, check the pricing. Usually the unit prices will be cheaper. The shipping is what will be much higher, and it takes usually longer to get from China. You may be able to get comparable pixels from a local vendor for roughly the same price. I can tell you that local vendors are going to have better customer service than somebody, usually the vendors will from China. So you just kind of have to weigh that on your own. You'll also need some pixel holders. I pretty much buy everything from Biscoyo. There are other vendors out there. I just haven't, don't have any experience with them. You can buy Coro, you can buy Strip, and these are things that you punch pixels into and they create shapes or put everything in a straight line. So you will need something of those, some of those. Let's see. You'll need a computer running xLights, so that will create your sequences. And then you'll need a scheduler or player. Usually people will not use the same computer that they're running xLights on, because that kind of ties that computer up while your light show is running. So you use a Pi or BeagleBone or a spare computer to run xSchedule. Most people have spare computers these days, so I'm hearing more and more people using computers, so that's that. But you need something to run the scheduler, and it's usually a different machine. Let's see, first year shopping tool or shopping list. I like the bootlace ferrule kit. You can get it from Amazon, and it's basically solderless connectors. So you put them on the ends of your wires, and then you can put those into the connectors for your controllers. Those are actually better than just tinning the wire and sticking them into the connectors. I've heard people have had problems with tinned wires backing out of connectors. I never have, but usually it's just because I didn't get it in there in the first place. But I haven't had any problems since I started using ferrules. Get a good set of wire cutters. You will need those. You will need some multi-conductor wire. I usually don't go any smaller than 18 gauge. It really just kind of depends on the prop or the string. If it's a long string, you may want thicker wire. If it's 100 or so, then 18 gauge is probably fine. But you really just kind of have to figure out what is best for your situation. You might need a few wire ties. Those come in pretty handy. And you will need some sort of weatherproof enclosure for your electronics, and you may need more than one depending on what your setup is like. This is not an exhaustive list, but these are kind of the main things that you'll need to start out with. And if you need help, So you probably, if this is your first year, you will come across, you'll get to a situation where you just can't figure something out. There are forums and Facebook groups that the forums you can search. Usually you can do a Google search and usually pull up a forum article that will answer a question. There's people hanging out in the Facebook groups all the time, so you can get an answer pretty quick there. Videos.xlights.org has got videos up there, various subjects. So depending on what you're working with, you may be able to find a video there. This room is very active, especially during lighting season. There's usually somebody in here all the time. So you can share your screen and look at your configuration and see what's going on, because it's usually computer related issues more, for that kind of support. There are local lighting groups that meet, and I don't know all of them, but just check Facebook and you can usually find a group either near you or in your same town. And then Christmas Expo this year, it's in Las Vegas, and I highly recommend that. There are some other shows, Trans World, I've not been to that, but that's coming up here soon. So that would be another opportunity to just talk with the folks that are in the hobby and get some questions answered there. And that's my presentation. I know it was pretty quick, but that's the basics in a nutshell.
Jeff, thank you very much again, and we'll see you at the expo, and keep up the good work on the videos.
Well, I'm looking forward to Expo, and thanks for having me.
Hey, no problem, man. See you later.